हेलो फ्रेंड्स, वेलकम टू BBSbaba फिजिक्स। आज हम लेजर्स के बेसिक्स के बारे में देखेंगे एंड आइंस्टीन्स ए एंड बी कोफिशिएंट्स को देखेंगे एंड व्हाई टू लेवल लेजर कैन नॉट हैपन। टू लेवल मिनिमम 3 लेवल्स चाहिए, ये सब के बारे में विल गो हेड नाउ। फर्स्ट ऑफ ऑल, द लेजर itself has its definition in its words. Laser light amplification stimulated emission of radiation. Okay, so emission stimulated होता है, spontaneous होता है. Spontaneous that happens on its own. Stimulated means that needs assistant. Okay, needs assistant. Okay, so let's move. So laser की properties पहले देख लेते हैं. Highly intense beam of light with characteristic. Highly intense beam of light, highly monochromatic. Highly monochromatic, purely monochromatic तो हो नहीं सकता, क्योंकि डेल्टा लैम्डा इज 10⁻⁻5 एंगस्ट्रॉम के तब भी उसमें स्पेक्ट्रल विड्थ होता है, राइट. हाईली फोकस्ड, यूनिडायरेक्शनल, डाइवर्जेंस 10⁻⁻5 रेडियन, ये सब प्रॉपर्टीज आप लिख सकते हैं. हाईली कोहेरेंट, कोहेरेंट मतलब स्पेशियल कोहेरेंट और टेम्पोरल कोहेरेंट, दोनों स्पेस और टाइम दोनों में कोहेरेंट होता है. कोहेरेंस स्पेशियल मतलब साइनोसॉइडल वेव ज्यादा देर तक मेंटेन करता है. ओके, नाउ पोलराइज. पोलराइजेशन होता है कि व्हाट इज पोलराइजेशन? when the electric field vector is the electric plane of electric vibration of electric field vector is called polarized. उसमें ठीक है, it's a plane of polarization, right? तो वो polarized होता है. अब mu nu d nu, it's like energy per unit volume at nu and nu plus d nu. इस प्लैंक्स फॉर्मूला बोलते हैं 8 pi h nu cube by c cube e to the power h nu by kt minus 1. ये प्लैंक्स के जो थ्योरी है उसके हिसाब से आ जाएगा. एंड इसको अगर लैम्डा के फॉर्म में लिखूंगे 8 pi h c by lambda 5 e to the power h c by lambda kt minus 1 आ जाएगा. ठीक है, तो ये लैम्डा के फॉर्म में आ गया. नाउ इफ एनर्जी डेंसिटी इज हाई, इफ न्यू इज हाई, इसका मतलब व्हाट? नंबर ऑफ फोटोन्स ज्यादा होंगे. नंबर ऑफ फोटोन्स ज्यादा होंगे तो सपोज देयर आर टू लेवल्स, दिस इज ग्राउंड स्टेट, दिस एक्साइटेड स्टेट. लेजर होने के लिए क्या चाहिए? वी नीड पॉपुलेशन इन्वर्जन. देयर आर फ्यू थिंग्स वी नीड टू पॉपुलेशन इन्वर्जन, दैट इज इन द हायर एनर्जी लेवल वी नीड मोर number of particles. So more number of particles in general, what is the case? In general ground state में ज्यादा particles होते हैं, right? But for the laser to happen, more number of particles to be in the excited state. So now see, so energy density high is more number of photons. Moving ahead, earlier in this also Einstein did the Maxwell Boltzmann distribution has been taken. Now see, Maxwell Boltzmann statistics, Ni is directly proportional e to the power minus ei by kt, correct? So Ni is a constant है. So n2 by n1, n2 by n1, what happens? This will become e to the power minus of delta e by kt, right? Delta e by kt. Now moving ahead, so n2 by n1 is e2 is equal to 2h nu. Suppose the two subsequent levels are taking, this is h nu, this is 2h nu. So what will happen? E to the power 2h nu minus h nu by kt. Okay, so n2 by nu is equal to e to the power minus h nu by kt. It is according to the Maxwell Boltzmann statistics. So we have seen this. Now moving ahead, the components of lecture. What are components of the lecture? Material for the laser. किस मटेरियल से आप लेजर बना रहे हैं? या तो सॉलिड हो सकता है, गैस हो सकता है, सेमीकंडक्टर, डाइज. एक एक एग्जांपल देख लेते हैं. सॉलिड रूबी लेजर विल have a dedicated video on ruby laser, as well as helium neon laser will see ahead. और excitation mechanism. Excitation mechanism क्यों चाहिए? Because we want to shift the particles from lower energy level to higher energy level. So what is the excitation mechanism? Excitation mechanism आपका क्या हो सकता है? ऑप्टिकल पंपिंग हो सकता है, किसी लाइट की फ्रीक्वेंसी आप दे सकते हैं जो ऊपर जाए, या आप प्रेशर क्रिएट कर सकते हैं, प्रेशर से हो सकता है, पोटेंशियल डिफरेंस से हो सकता है, थर्मोडायनेमिक्स हीटिंग से होता है. देयर आर मेनी different ways you can provide excitation mechanism. Feedback mechanism क्या होता है? Feedback mechanism, for example, whole some part of the are sent back for the feedback, right? Not every पूरा जो है नहीं निकल जाता है, कुछ पार्ट फीडबैक के लिए दिया जाता है. ये दैट इज व्हाई दिस इज कॉल्ड पार्शियली, दिस इज पार्शियली सेमी सिल्वर्ड मिरर, राइट? पार्शियली सेमी सिल्वर्ड मिरर. मिरर एक्ट्स एज अ नोड. मिरर एक्ट्स एज नोड मतलब क्या? कि यहाँ पे नोड बनता है वेव्स में, है ना? तो मिरर एक्ट्स एज अ नोड, राइट? तो फीडबैक हो गया. तो कंपोनेंट्स क्या हो गया? मटेरियल किसका है, एक्साइटेड मैकेनिज्म क्या है, फीडबैक मैकेनिज्म क्या है, ये सब लेजर डिटरमाइन करते हैं. नाउ रेजोनेटर कैविटी अरेंजमेंट के फीडबैक डिटरमाइन करता है. How the resonator cavity has been made, that determines the feedback. Now moving ahead, lasing material, जैसे रूबी है Al2O3, उसमें क्रोमियम डाल देते हैं. विल सी रूबी लेजर एंड हीलियम नियॉन लेजर हम अलग से देखेंगे नेक्स्ट वीडियो. नाउ मूविंग अहेड, so E2 is a higher energy level, E1 is a lower energy level. Earlier there are more number of we few we first, to happen this we need more number of particles in the higher energy level. Population inversion we need to have. How we can have population inversion? Through excitation mechanism, right? Of unit volume of lasing material we are taking population inversion n2 greater than n1 for achieving इसको अचीव करने के लिए क्या करते हैं, यूज करते हैं एक्साइटेशन मैकेनिज्म। ठीक है, ये हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल से है कि डेल्टा ई इंटू डेल्टा टी इज ग्रेटर देन एच क्रॉस बाई टू। इसका मतलब क्या है, इफ मोर द एनर्जी, हाइयर द एनर्जी, लोअर द लाइफ टाइम। बहुत कम लाइफ टाइम होगा, फॉर एग्जाम्पल इसका 10⁻² ही सेकेंड्स होगा, और इसका उससे ज्यादा होगा, फॉर एग्जाम्पल 10⁻1। एग्जाम्पल दे रहा हूँ, विल सी। Now, energy high, lower lifetime, stimulated emission, and there are two types of emission. One is stimulated, and the other is spontaneous. Stimulated, I have already said that it needs assistance, and spontaneous is on its own. Obviously, when spontaneous is happening, there is no phase relationship. There is direction is not known, random, not in the same state of polarization. So this is not very effective. It does not give us the intensity of light that the laser gives. But when we have spontaneous emission, you see what we are doing. Suppose we have achieved population inversion, right? We have achieved population inversion, more number of particles are there. So when you are throwing photons, when the photons are being interacting of h nu, and we have to make sure that the energy difference h nu and this h nu should be same, because that then only same energy we are trying. Okay, so suppose this photon is interacting with the particles in the higher level. So this photons, what it does, it tells the particle to go down. When the particle go down, it also releases the value of energy h nu, and again this is h nu, so it becomes 2 h nu, and these are in the same direction, same energy, same frequency, coherent polarization. So it increases the intensity of light. So that is what we are, no, the laser action is highly coherent, highly unidirectional, highly intense. Okay, now, so when we have spontaneous emission, we don't have phase relationship, even if it can go on its own, but it does not have a phase relation. Suppose plus minus, so it is not going to contribute in a certain way. Random, not in a state of process. Spontaneous emission is that phenomenon where the particle jumps from higher level to lower level. Emitted photons in that process do not bear any definite direction. अगर डायरेक्शन ही डेफिनेट नहीं है तो फिर कंस्ट्रक्टिवली इंटरफेयर नहीं कर पाएगा, राइट? Not no phase relationship. Stimulated emission is what? Stimulated emission, suppose energy higher, atom in higher energy level E2 is being interacted by h nu, then the atom goes in the lower energy level and new photon emitted. Earlier photon was already there and new photon is emitted. Okay, so feedback mechanism से more and more number of photons are being emitted. Principle क्या है? Principle is like we need to cut down spontaneous emission. For lasing action to happen, we need to cut down, मतलब जो spontaneous emission ना हो, because why? क्योंकि it's not directional, and for laser to happen we need directional in जो है, we need direction in a certain direction the photon should go. So A to be decreased and B to be increased. B is signifying our spontaneous emission, or A spontaneous, B stimulated. Now, unit volume of lasing material dN2 by N2 by dt. What is like? We are trying to say probability of emission. Suppose dN2 is number N2, dN2 number of particles has gone down. Okay, so probability was what? dN2 by total N2, right? This is probability. We have divided by dt because we are trying to measure in per second, right? So spontaneity, probability of spontaneous emission will become, probability of emission will become yeah, probability of spontaneous emission. Okay, probability of spontaneous emission is A. We are denoting with A. This is called Einstein A and B coefficient also. So A21. Why we are writing 21? Because it is coming from 2 to 1. A12 cannot happen. Why cannot happen? Suppose this is, so spontaneously from lower energy particles cannot go to the higher energy particles, but spontaneously energy, higher energy particles can go to the lower energy particles. Okay, so A12 नहीं होगा, but A21 will happen, right? Similarly, so probability is what we have to just write dN2 by N2 into dt, as we have mentioned here, right? Now, so what is dN2? dN2 would be A21 N2 into dt, correct? Similarly, we are trying to see probability of stimulated emission. So stimulated emission, when we are writing stimulated emission, then we are writing 2 to 1, because higher level to B21 is the probability of stimulated emission. 2 पहले आएगा क्योंकि 2 से आ रहा है 1. This will become what? dN2 by N2 into dt. But यहाँ पे we need to multiply by mu nu. Why? Because this is the probability of stimulated emission is dependent upon the unit volume energy density, right? Because जितनी ज़्यादा energy density होगा, more number of photons will be there, and that will be helping us in stimulated emissions, right? More number of photons will be there, that will be interacting with the particles in the higher level, so that is why mu nu is multiplied. So when you see B12 mu nu, here also mu nu, okay, then dn2 will become what? dn2 will becoming mu nu n2 b21 into dt, right? b So n2, so 1 and 2 we have calculated. dn2 due to spontaneous emission and dn2 due to stimulated emission, we'll add those both of them. And again b21, b21 was emission, b21 from coming from higher level to lower level. b12 will be what? Stimulated absorption. b12 will be like stimulated absorption, right? Now, what we are trying to say, number of photons collides with the ground state and some excited state. Exactly. Some excited states also, it will be uh, interacting. But if we have more number of particles in the excited state, so more interaction will be happening in the excited state particles. That is why we need population inversion. Okay. One assumption is there, the interaction is by one interaction. One photon will be interacting with one atom. Suppose this is the assumption. Now, N1 and N2 are in thermodynamic equilibrium. When we are saying it is in the thermodynamic equilibrium, okay, so what is happening? So, number of particles, that is dN2 total, is equal to dN1. The number of particles that is total coming down should be the number of particles going up. So, what we are doing, dN2 we are is equal to dN1 we are doing. What was dN2? For example, for A21, change in number of particles going down. Number of particles going down, A21 was like dN2 by N2 into dt. So dN2 was like A21 N2 into dt, ठीक है, common language. Similarly B21 N2 into mu nu. Okay, this was dN2. Now number of particles going up was like B12 mu nu dt हो गया is equal to dN1, change in one, right? Same we have written dN1. So this is the most important line. So we equate both of this because we'll be writing in thermodynamic equilibrium. N1 and N2 are in thermodynamic equilibrium. So what is sent up has to come down. Okay? Whether it can come down by spontaneous or whether it can come down by stimulated. For laser action to happen, we have to dominate the stimulated one, right? So when we compare, then we'll get mu. You take the common, we'll get mu nu is equal to A21 N2 by N1 B12 B21. Now टेक कॉमन B12 को आप ऊपर नीचे से B21 को डिवाइड कर दीजिए, दिस विल बी लाइक A21 बाई B21 और N2 से भी डिवाइड कर दीजिए, N2 ऊपर N2 है, तो नाउ वी आर डिवाइडिंग N1 बाई N2 B12 बाई B21 माइनस ऑफ N2, है ना, माइनस ऑफ N2 बाई N2 से डिवाइड कर दिया ऊपर नीचे, राइट? तो इसका मतलब क्या, यहाँ 1 आ जाएगा and this will be like from ये मैक्सवेल बोल्ट्जमैन स्टैटिस्टिक्स से आएगा, करेक्ट? N2 is equal to what? N1 e to the power minus of delta E by kt, करेक्ट? यहाँ पे h न्यू है तो माइनस, तो N1 ऊपर है, N1 ऊपर है तो क्या हो जाएगा? E to the power h nu by kt, right? So B12 by B21 e to the power h nu by kt by 1. Now we know from Planck's formula E is mu nu is equal to what? 8 by h nu by c cube e to the power h nu by kt minus 1. Now compare both. So what will become? A21 by B21 is will be becoming what? 8 by h nu cube by c cube, right? Now see this. What for laser action to happen, we want stimulated emissions to happen more, but A is directly proportional to nu, so A is directly proportional to nu. So for higher frequency particles, for example X-rays, so it is very difficult to achieve lasing action with X-rays. Why it is difficult? Because in that case spontaneous emission will be dominating, because A21 is directly proportional to nu frequency. Okay, so this is it, and you can see that from this comparison B12 is equal to B21, that is 1. So you are saying why this is 1? What this means, that stimulated emission for B12 is what? B12 is what? Stimulated absorption, correct? B21 is what? Stimulated emission, right? So it signifies is equal to 1. It means what? Both stimulated emission and stimulated absorption both are same, probability of happening both of them are same. It means we cannot achieve the lasing action in two level laser, right? क्योंकि both जो नीचे आ रहा है उतना ही स्टिमुलेटेड इमिशन, जितना नीचे आ रहा है उतना ही ऊपर चला जा रहा है, तो लेजिंग एक्शन के लिए we need that population inversion to happen, है ना, stimulated, we need population inversion to happen for stimulated emission, जिसका जो है stimulated emission हो सके, but this is not happening, right? So two level laser can't be produced. Minimum number of energy levels required are three. So that is why at least three levels are required for lasing action to happen. If two levels, there will not be any accumulation. ठीक है, accumulation ही नहीं हो पाएगा. For laser we require more particles in the excited state, more photons collide, more photons emitted, right? ज़्यादा होगा तो again देखिए 10 to the minus 2 second, and we made an intermediary level 10 to the minus 3 second. So here population inversion will happen, and this will corresponding to our lasing action, right? So this is it for this module. We'll be coming about ruby laser and as well as helium neon laser. So thank you very much. Thank you for watching.